Alright, I'm not here to give a math lesson with this one. Everybody knows how numbers work. Especially anybody that'd be interested in watching this. But it's just to, this is the first part will be to give an idea of what I'm looking at on the second part. Okay, if you take all the numbers, I just stopped at 12. If you take all the numbers 1 through 100, and let's say you divide 1 by 1, it gives you 1. If you divide 1 by 2, it gives you a 0.5, by 3, 0.333, and keeps on going. By 4 gives you a 0.25. If we get out here and divide 1 divided by 12 gives you 0.083 and keeps on trucking with the 3's. Same thing with 2 all the way through 100 divided by 1 through 12. Okay, you don't really see anything except just a bunch of numbers pretty much. You see the 4's, a lot of 3's afterwards, 7's, 4, 5, but don't really see no patterns as far as just looking. Okay, and this is just basic math. Multiplying, which is division, will be like subtracting, and multiplying will be like adding, taking away, giving more to. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 2 times 2 is 4. 6, just multiplication tables. All the way down, 100 times 12 gives 1200. Simple first grade math. You take those numbers and sum them up. So you've got 1 through 9. Here's 1 through 9. And then 10 sums up to 1. 11 sums up to 2. 12 sums up to 3. Still, you don't really see any patterns. You can see a straight line across wherever 9 comes up for your 9's. And then subtraction. 1 minus 1 is 0. 1 minus 2 is -1. 1 minus 12 is -11, so on. And summing those numbers up to give us one single digit. Same thing with addition. 1 plus 1 is 2. 1 plus 2 is 3. 12 is 13. And then 13 sums up to 4. So you see, you don't really see anything as far as pattern-wise, except for your lines coming down, your lines going down this way. Now we take those numbers, we add a little color to them. Then you can start seeing the patterns a little better. Again, this is the same data, just color added so you can see what's going on. Of course, green is going to be even. Stoplight, red light, looking at it like. Green's even, red's odd. Green even, red odd. Will be all the way across. This is your same table division, and you can see that you've got 1 even and even odd all the way down through. You get over to here, you've got even, odd, odd, even, odd, odd. And then the same thing here. Then you start jumping into the 3. So you've got 3 odds. So you're just gaining 1. Gaining 1 every time. Until you get down to 12. And then you've got 12 results here. But you can see the patterns. Got the same pattern all the way through. It's just just the patterns that the numbers make, just using simple first, second grade math. You get into multiplying, then you get these patterns here. You get just like it's like a checkerboard. Again, I run over to 12 so you can see just a touch more. Now if you take 1 times 1 is 1, 1 times 12 is 12. You really see the patterns. It's just a straight ahead checkerboard pattern. If you sum those numbers up, you get what you see here, and you see this pattern coming across here, 2, 4, 6, 8, coming down 2, 4, 6, 8 with the 4s on each corner. You start over on 10, which is 1 summed up. There's your 1. You start seeing the pattern come about again, and it'll keep going this way as far as you want to go, keep going that way as far as you want to go. Same thing, 2, 4, 6, 8, till you get over to 5. Then you have that same pattern.
Fun to drive wherever you go.
The same pattern in reverse that you have up here. Okay, you have your lines coming of 9 straight down, cause anything all these numbers are going to sum up to 9. 9 times 1 is 9, 9 times 2 is 18, which is 9. So you're going to have 9 all the way down. Then you're going to have this area here with your 9s again. 9 going this way. And you have straight line, straight line. Then you have this little section here. These little squares inside. 9, 7, and 3 and 3 gives you a nice little pattern. Here you have again, which will actually be right here. With your 6 and 8 kind of setting off by themselves. Drops down to 6, comes up to 8 again. So you just repeat over and over and over. Okay, on your 1s, you have 1 through 9. 2, 3, all the way to 9. And if you come over to 8, you have the same thing except it's reversed. 9 through 1, the opposite side of this pattern. So it flips. 2s, I've got them color coded. You've got 2, 4, 6, 8, 1, 3, 5, 7. You come over to 7, you have 7, 5, 3, 1, and 8, 6, 4, 2. And 1 is 8 is 9, 2 and 7 is 9. So you have the pattern going this way on 1, it reverses, same pattern this way on 8. Okay, we've got the 1 and the 2 and the 7 and 8 covered. We have the 3. You have your 3, 6, 9, 3, 6, 9, 3, 6, 9. It just goes all the way down, keeps going. 6, 3 and 6 is 9. Same thing, except you're starting with 6 here. And 3, 6, 9, all the way down, as far as you want to go. 4 and 5 now. You can kind of see the back to back here. Kind of where the line separates. You see that it's pretty much a line all the way down. And you have 4, 8, 3, 7, 2, 4, 8, 3, 7, 2, 2, 6, 1, 5, 2, 6, 1, 5. Have a reverse here and here. And then you have the reverse here of here. So you can definitely see the patterns that the numbers make. Even going this way with the 2s, 2, 4, 6, 8, 1, 3, 5, 7, 9, 2, 4, 6, and it starts over again. 3s this way, 3, 6, 9, 3, 6, 9 all the way across. Same patterns this way on the 4 as you have here. 5 is here, same as you have here. And then you have subtracted, which is just giving you a checkerboard again. Okay, this is just to help see the patterns that the numbers create, just working as numbers work. Subtraction again, same thing as it was on the standard sheet here, just colorized. You just have a checkerboard and you see your patterns going diagonal down, except you're going largest, you're getting smallest to largest as you're going down. These are those numbers summed up to a single digit. There's your 9 from your 9. And positive on the positive side, which is addition. you have the same exact thing in reverse with your patterns all going down, smallest to largest, from right to left. So you can see that pattern or numbers actually do make a pattern, just working them as numbers work, especially in this area here where you get these patterns that repeat constantly. Then you have your patterns which are, they separate and reverse somewhere down the line. And then we get over to this area, which is what I've been posting on, and the way that the numbers work out in a completely random game. You have your, like I said, this has been done with I've tested this with a game that involves balls bouncing around in a hopper and computer generated RNG lottery draws. Like I said, there are 10,000 possible combinations. If you just count the numbers up each time they happen, that you can have. There's 0, 0, 0, 0, all the way down to 99, 99. Of those 10,000 combinations, for the game that I'm testing here, or one of the games, 3,000 of them have actually come about out of 227,500 movements, and these are those. I'm not gonna, I'll just kind of scroll through. Okay, and we sum those numbers up, you get 0, 1, 9, 1, 2. You don't really see anything again but a bunch of numbers. You can kind of see it if you're paying attention to it. Like here you've got 1 and 8, which is the difference. 1 will be the difference between 0, 0, 0, 0 and the 3 zeros and the 1. 8 will be the difference between 9 and 1. So out of these 3,000 possible moves, this is the difference from one to the next. Then you can start to see the 1, 1, 1, the 9, then it skips to 2 and 9, 1 and 1 and 9. I'm sorry, 2 ones and then 9, 2 ones and 9. And then it just repeats till you get down to here. The total of combinations that have occurred 100 times or more are here. Since we're not really seeing anything but numbers, I'll make it go. The sum of those numbers, the difference between this number and this number, again, like I posted already, you can see the 11s and the 10, 11, 1, 11, 10, 11, 11, 1, and the sum of those differences. So 1 and 1's 2, 1 and 1's 2, 2 and 2 is 4. Simple kindergarten math. Same thing with the numbers that have been hit 1 time to 99 times. The numbers that have, I'm sorry, the combinations that have occurred. This is not actual drawn numbers. This is the movements of those drawn numbers. And there are 3,000 total movements that have occurred. 871 have been 100 or more, and 2,129 have been between 1 and 99 times. 7,000 possible movements have never happened. And these are those. Here you see the ones with the 5, and then you have ones with a 4. That is the difference between each one. Just looks like a bunch of numbers. And then this area is all I've done is just put all the totals These are all the numbers, the combinations that are possible. These are the 3,000 that have occurred, the 100, the combinations that have occurred 100 times or more, that have occurred 1 through 99 times, and have never occurred. Okay, just looks like a bunch of numbers. Same as over here. So we add a little color to it. Okay, and we start to see a little better. Out of the 3,000 that have occurred, you have the sums of those numbers, 0, 0, 0, 1, sums up to 1, 3 zeros and a 9, sums up to 9, and you have 0, 0, 0, 0 at the top. Okay, that's 0, 1, 9, 1, 2 from the 11, 3, 3, 4, the 2 5s from the 23 and the 32, and you can start to see a little pattern forming if you pay attention to it. There's the 1s, you go with the 2, which is a nice even number, 1 0, 1 2, 1 4, 1 6, and 1 8. Okay, if you go with all the numbers that have been drawn, or the combinations that have happened 100 times or more, there's your 1 0, your 1 2, your 1 4, your 1 6, and your 1 8 sums with these numbers. And then you have 1 3 5 9, which are these numbers here. And then you have the 1 that comes back out to close this set. Then you start over, you leave off the 0 with these numbers to go 2 4 6 8, and then you have 1 3 5 7 9 1. You're adding a 7, and you're also adding 3 onto it, so you're jumping up one, actually 2 more here, but you're adding 1 more on it also. So you've got 5 sets here, 4 on the even, then you drop down to 3 on the next one. So you have 2 4 6 8, then 4 6 8 on your sums. Skip down to the next time it occurs. There's 6 and 8 on your sums from the 4 6 8, and you skip down 1 more, and you've eliminated all the numbers except for 8. So it's like pattern here, pattern here, pattern here, then it here, stops here, down to 2, starts a new pattern, starts growing, 2 4, 2 4 6, 4 6 8, 2 4 6 8, 2 4 6 8 again, stop, starts a new pattern. Instead of the 2 4 6 that we have here, we're on a new pattern. We get rid of the 2, start with the 4, and we start with the 4 6 8. New pattern, 2 6, 2, 8 2, 2. Okay, so you can kind of see the pattern there. Same thing here with this one. 1 3 5 9 1, 1 3 5 7 9 1, and added 3. So again, this one didn't have the 7, picks it up here. Then you have a longer pattern here with the same numbers again. You drop the 1 just like on the even numbers, pick up with the 3, and then you end with the 7. So you've got 2 7s and 2 5s on this one, where you had 2 5s here and 1 7. Then you have a longer pattern with sorry, we're down here. A longer pattern here from here. You can see the patterns. Then you have your differences on your numbers that have been drawn 100 times or more. 11 minus 0 is 1, 22 minus 11. So you have 11, 11, 11, 11, 11, 11, all the way down to here with sums of 11. 9 times 1 through 11, and 1 through 9 times 11. That's what you have here, which is all sums up to 2. Okay, this is results from a completely random occurrence. This is balls bouncing around in a hopper. It does the same thing for computer generated draws. It's the same exact result. You have 3,000 combinations that have happened for both games, both methods, sorry, and 2 different games. It's been 227,500 combinations on the one draw. That's 227,500 movements, which that means that all of these possibilities could come about from those movements. But only this 3,000 has. Only 871 have 100 times or more, and only 2,129 have occurred 1 through 100 or 1 through 99 times. I've got to change this. But you can see the patterns. If you watch for them, you can pull them out. Where was the one that I was looking at? I guess this one. Okay, the numbers that have happened 1 through 100 or 1 through 99 times, you kind of have the same pattern as you do over here, but you don't get into the double digits. I can show you the patterns. I'll give you a quick scroll down through all of them. You can pause the video whenever or wherever you want. Okay, on the 100 or not the 99 through down to one-time happenings, you can see you have your patterns here. 191 starts out the same as it does on the 3,000 or more, except you have the odds, the 9 here. And actually it is the same thing over here, except yeah, starting out with 0. This one starts out with 1. Then you have the double 2s, the double 4s, the double 6s, which you have here, except these are odd, these are even. There's your 2 3s, 2 5s, 2 7s, and 2 9s, 2 2s, 2 4s, 2 6s, and it breaks into a single digit, a single, a single, a single. Then you have 3 odd, a single, even, an odd. There's 2 odds, 2 odds, and 2 odds. So your patterns are there if you just look for them. They grow or they shrink depending. And then you have your sums where over here you had the 1s. Over here they switched to 2s. Why, I don't know. But it's just the way it works. You have 828 here. Drop down here, you've got 282. And then you have your numbers that have never been drawn. I'm sorry, the occurrences that have the combinations that have never happened. On those combinations, you have the sum of 2, 3, 4, 5, all the way to 8. Then you skip down to 4. So you jump up just like you did on the rest of these. 2 to 4, 2 to 4 on the next one, 4 through 9, and then you have the 2 and the 6. So it's like it done over here with it runs and it stops. I don't know why it's doing that. It's just, it doesn't seem possible that these kind of results are from something that's completely random. Here you have the 1s with the 5. Then your even, single even, you have a bunch of 1s here with the 4, which is even, a bunch of 1s with a 4, and it does that all the way down. Now if you watched the other video and looked on Lottery Post on my thread on this, you'll see what these combinations are about. They're just the movements that the numbers make, like a number being even. Every time a number's even, it counts up one more time. Every time a number's odd, it counts up one more time. So you have all these combinations that those numbers should count up to. But out of 10,000 combinations, you're only getting 3,000. You've only got, you've got 7,000 that have never happened. So why is it just 3,000? Why is it two completely different methods of choosing random producing the same results? I don't know. We'll keep digging. Thanks for watching.